In this video, I'll be showing you how to evaluate trig functions, specifically inverse trig functions that are composed in a normal trig function and a trig function that's composed in an inverse trig function. We'll also talk about how to write a trig expression as a purely algebraic expression. So we'll start off with number one. Okay, how about we're gonna first let theta equal to sine of negative 1 of negative 2 over negative root 2 over 2. So then we can rewrite this as sine of theta is going to equal to negative root 2 over 2. So now we can rewrite sine of, we know that sine of negative 1 of x is going to equal to x as long as x, and we know this is like true as long as x is in the range of negative 1 to 1, and it's true. So that means that x is just like, this is just x, so that means that that's negative root 2. So then you know that the answer is negative root 2 over 2. Hooray, that's awesome. Okay, so now we can move on to next question. Okay, so we're gonna make the inside equal to theta again. So then we rewrite that as cosine of theta is equal to 3 over 5. So now we can rewrite this as cosine negative 1 of x, and that's gonna equal to x for when x is on negative 1 to 1. So that means that, and it is, so it's just equal to 3 over 5. That's the simplified expression. Now let's move on to 3. So set the inside equal to theta again. So now we can rewrite this as tangent of theta is equal to negative 4. So now we know that tangent of tan of negative 1 of x is equal to x for all real numbers, and this is a real number. That's true. So that means that, again, it's just negative 4. It cancels out. So you need to remember that it's just the same thing. That's the same negative 4. 3 negative root 2 over 2, yeah. So, okay. Same thing for this. Honestly, you could just cancel it out. But we're gonna prove it with this. That's just theta. So then you can rewrite this as a sine 5 pi over 6 is equal to 1/2. And remember that for arc sine of negative 1, sine negative 1 of 1/2, it has to be in arc sine x range, which is negative pi over 2 pi over 2. And remember that sine of pi over 6 is equal to 1/2, and also that pi over 6 is also in negative pi over 6 to pi over 6. So that means, yeah, that's true, that's correct. Alright, it's just pi over 6 again. Or this is actually pi over 6. It's not 5 pi over 6 because that's actually out of the range. So, here is, almost made a mistake. Warning, it's not just that. You have to adjust. You have to choose correct angle. Okay, so now let's move on to this. So remember, this trick was only for it only works you have to check the range first, but this one, it didn't work. Now for 5, let's just do 5. So we can rewrite as cosine pi plus pi over 6, and then that's going to equal to negative cosine pi over 6, which is going to equal to negative root 3 over 2. So now you're going to have cosine negative 1 over root 3 over 2. And remember that arc cosine x range is 0 to pi. So that means that in 0 to pi, cosine equals negative root 3 over 2 at x is equal to 5 pi over 6. So that would mean that this is just 5 pi over 6. So, yay. Now, we have these. So tan 5 pi over 6, you can rewrite this as tan pi minus, pi over 6. That's going to be equal to, negative tan pi over 6. And then this is going to be equal to negative 1 over root 3, rationalize that denominator. Root 3 over 3. Okay, no, wait. Yeah. But it must be in arc tan x range, which is negative pi over 2, pi over 2. And also, that's equal to negative pi over, so remember that this is equal to negative pi over 3 as one solution. Oops. And also, it's also equal to negative pi over 6. Oops. Wait, did we just do this? Okay, yeah. That's right. And it's all real numbers, actually. I don't know what I was just saying. This is all real numbers. Not all real. What am I saying? This is negative pi over 6. Okay, ignore what I just said. It is in negative pi over 2, pi over 2. So that means it's right. So that means it's just negative pi over 6. Great. Now let's move on to this. Number 7. Okay, we can honestly move these over a little bit. We have a lot of room. So, let's say that we know that sine negative 1 is only defined for x is a part of negative 1 to 1, and we know that 5 over 3 is going to be greater than 1. Therefore, we know that sine negative 1, 5 over 3 isn't going to be real. So therefore, we know that this is, this is going to be undefined. This is going to be undefined. So let's, now for this, cosine negative 1 of x is defined for x is inclusive of negative 1 to 1, and we know that 2 is not on this range, so that means that it's undefined. There's no real value. Yeah, so now we're going to learn how to rewrite trig expressions as algebraic expressions without trig. So now for this, we're going to let this equal to theta. So now we can rewrite this as cosine of theta is equal to x. Basically, you're just flip-flopping it. And then you know that theta has to include, it's on 0 to pi. So that means that sine of theta has to be greater than 0. And now let's draw, for these, you have to draw a triangle for your strategy. Now, you see that adjacent is going to be equal to x, and the hypotenuse is going to be equal to 1. And the reason why we know this, we can, over here, that's adjacent, that's hypotenuse, and we're going to make this theta. So adjacent is going to be x, hypotenuse is going to be 1, and then we have the opposite side. Now the opposite side, this is going to, remember we have Pythagorean theorem for, just so you can see, a squared plus b squared plus c squared, x squared, plus, we're going to call this, we'll just call this y for now. Y squared is going to be equal to 1 squared. So now we can just rewrite, we want to solve for y, right? So that means that we have y squared is equal to 1 minus x squared. So then you take square root y is equal to 1 minus x squared. Great. So now we just have this is equal to 1 minus x squared. Now we're gonna solve for sine of theta is equal to opposite over hypotenuse. So therefore we know the opposite side is 1 minus x squared. We know that the hypotenuse is just 1. So that, and we know the domain is going to be -1 is less than or equal to x is less than or equal to 1. So yeah, this is just going to simplify down to 1 minus x squared. So that's just your answer, because we were just solving for sine of that angle. That is sine of that angle. So now we can move on to the next. So let's say we have secant of tangent of -1 of x. So, okay, let this equal to theta. So then you can rewrite this as tangent of theta is equal to x. But that's equal to the opposite over the adjacent. Therefore, that's equal to x over 1. So now we can rewrite this using a triangle. And then we have that as theta. And then we have this as the adjacent. And this is the hypotenuse. That's the opposite side. So that means the adjacent is going to be 1. The opposite is going to be x. And then we need to solve for the hypotenuse. So that we have 1 squared plus x squared is equal to the hypotenuse squared. So that means we have 1 plus x squared is equal to hypotenuse squared. Okay, yeah, so now we square those down. We have hypotenuse is equal to square root of 1 plus x squared. So again, we can just copy that right here, label that there. Now, we're taking the secant of that theta, so we're finding secant theta, which is equal to 1 over cosine of theta, which is equal to, again, or we just know it's just the reciprocal of cosine of theta, is just the opposite over adjacent, so it's just hypotenuse over adjacent. So then that's going to be 1 plus x squared over 1. So yeah, that just simplifies down to 1 plus x squared, and then that is going to be your answer. Hopefully you found this video helpful. If so, please subscribe. Thanks for watching.